Good day, Dr. Cheng and Dr. Asfani. We are Group 13, and our title is Smart Office and Environment Monitoring System for Abnormal Temperature. My name is Teo Zhongheng, and my teammate is Tae Jing Win Fong, and Wen Q. Now I'll be passing through to the first presenter.
Hello sir, my name is Tae Jing. Now I want to present about the background of the smart office and the history of the smart office. By employing the Internet of Things technology to create a smart office, business hope to make workplaces safer, cut costs, and recoup money lost due to the pandemic. Inventory management and better security are two useful solutions for workplace and opening in the post-COVID era. When IoT technology is used in the smart office, it means that numerous gadgets in the office are connected to the internet and can be controlled remotely. There are several ways to benefit from smart office technology. Office climate control is easier, and the eye tracking system and security. So to achieve the successes of smart office technology, the following principles should be followed. The first, practical and convenience. Second, standardization. And the third one, conveniences. And the history of the smart office. The concept of the smart office came from smart home technology. Smart home is the embodiment of IoT under the influence of internet. Smart home connects various devices in the home. So the home appliances control, lightning control, telephone remote control, indoor and outdoor remote control, anti-thief alarm, environmental monitoring, HVAC control, infrared forwarding and programmable timing control, and other functions and means. So compared to the ordinary office, smart office not only have traditional working functions, but also have constructions, network communication, information applicants, and equipment automation, and provide a full range of information interaction functions and even save money for the various energy costs. Next, I will pass to the next group member.
So now I'll be talking about the future trend of smart office. So the future trend of smart office is looking promising as our technology will advancing in decent rates, which allowing us to come up with much more variety of IoT device. Next, IoT has become much more popular in the recent years, as study shows that in 2021, there were a total of 12.3 billion active IoT connections globally, and in 2022, the number has increased to 14.5 billion. After that, with the growth of 5G, which provide low latency, higher speed, ubiquitous coverage, and energy efficiency, this provides a much more reliable connectivity for the IoT system, which allowing them to have a much more better performance. And the last one is smart office is getting much more attention as the market size was valued at 31 billion in the 2020 and it is predicted to reach 90 billion by the end of 2030. This is due to the rising need for safety and security system at the workplace and also surging demand for the sensor-based network for energy efficiency. So now I'll be talking about the problem statement. So, the smart office is lacking detection for fire hazard as it is mainly being used to improve the efficiency of the employees. If a fire hazard happens in the office, it will cause a great loss such as monetary resources, data, and even lives. Some of them may have simple fire detection system, either using the reconnection or through detecting the temperature, but it can't detect if there is a person fainted or trapped inside. So, what could be done is that we can develop a smart office that is capable of detecting an abnormal temperature in an office room, and once it's detected the fire, it will use the camera to detect if there is any person there. If a person is detected, it will notify the admin about the situation of the specified room, such as the temperature and is there anyone inside the room. So now I'll be talking about the objective. So our main objective is to develop a system which will detect abnormal temperature and the existence of people in the specific office room. We'll be using AWS as the cloud platform to develop and implement the safety system for an office room. To implement the notification service, we'll be developing a sensor to gather real-time information about the temperature of the room. Once the abnormal temperature is detected, it will use the tool provided by AWS to notify the admin. The system will take a picture of the current office and send it to the system created using AWS. Once the picture reaches the AWS system, the person detection would be done on the picture to see is there any person in the office or not. And based on the result, the system will notify admin through email. And now I'll be passing to the next presenter.
Good day, sir. My name is Wing Fong, and the diagram as shown below is our proposed solutions architecture diagram. In this diagram, there are 6 AWS services being used, which are the AWS IoT Core, DynamoDB, SNS, S3, Lambda, and the recognition. Besides, the Raspberry Pi would act as the sensor to detect the surrounding temperature, and it will send the data to the IoT core, and the IoT core would store the temperature data to the DynamoDB. So when a sensor detects abnormal temperature, in this case 70 or higher, the Raspberry Pi would send an image of the room and upload it to the S3 bucket. Meanwhile, the IoT core would trigger the Lambda to perform the person detection received from the Raspberry Pi using the recognition to see if there is anyone in the room based on the image stored in the S3 bucket. After the detection process, the Lambda would trigger the SNS to notify the user or admin that there is abnormal temperature being detected from the room and the existence of people in the room.
Hello, sir. My name is Ng Wing Q, and I'm going to present to you the study of different IoT platform. Firstly, is the IoT is also known as the Internet of Things, which collect data and exchange data via the network with minimal contact. It also increases the productivity and efficiency of the business operation. And then some types of the IoT platform that will be discussed in this study, which is Amazon Web Services AWS IoT Platform, Cisco IoT Platform, and IBM Watson IoT Platform. First is the AWS IoT Platform. It uses the cloud to collect, store, and record data, have various services such as EC2 and Amazon DynamoDB. It uses the MQTT and HTTP as the communication protocol with the encryption of TLS 1.2, and they have the benefits of being interchangeable. AWS also supports up to 90 security standards, compliance certificates, and encryption to other services within the platform. It utilizes the limitless server capability and flexible scalability. The key services of AWS IoT platform is AWS IoT Core, which is the main heart of AWS IoT suite. It manages the device authentication, connection, as well as communication. It supports up to 1 billion devices and offers SDKs for Android and iOS. The second is AWS IoT Analytics, which automatically collect and clean data before transmission, which allow user to broaden knowledge amongst external information and able to integrate easily with Amazon QuickSight, Jupyter Notebook, and Amazon SageMaker. The third is FreeRTOS, which is Amazon facilitated real-time operating system that allow easy embedding and programming of low-end devices and provide secure connection to AWS IoT and hardware component. Lastly is AWS IoT Greengrass, which extend analytic management and other services capability to other high-end devices and allow users to write code to the cloud and deploy locally. The second is the Cisco IoT Platform, which is an end-to-end IoT architecture built upon Cisco's industry-leading network and security capabilities, which provides network monitoring, asset tracking, worker safety, connected car, fleet management, and predictive management. It also uses MQTT as communication protocol because it is a dominant standard in IoT communication. It allows users to receive information however they want, as well as very simplistic. Cisco IoT also offers OT visibility and threat detection and converge threat investigation and remediation. The key services of Cisco IoT is Cisco IoT Control Center or XJasper, which is have machine learning that analyze up to 3 million events to improve themselves every day, have eSIM as a service which simplifies SIM portability with different operators worldwide, and have 5G readiness that support 5G non-standalone or NSA. The second is Cisco Kinetic IoT Operation Platform, which is Gateway Management Module, which monitor industrial gateway while enabling remote configuration, edge and fog processing module, which push data management process selected from cloud to nodes and devices, data control module, which perform opposite of function and upload data to cloud application from device. The third is Cisco IOX, which is a Linux-based operating system which manages the network's fog application. And the last one is Cisco Edge Intelligence, which extract the nodes data and analyze them and send the data to adequate application for information after analyzation. The third and last IoT platform is IBM Watson. It is a cloud host service that is fully managed to simply derive value for IoT devices and do not use IBM cloud hardware to run, which allow continual data collection. It provides layered security control and also protect the compute cycles. It practices the scanning of source code, dynamic modeling of threat, and penetration testing. It also uses MQTT as the communication protocol since it is invented by IBM back in the 1990s. It is lightweight and flexible and allow compatibility across various IoT platforms and as well as devices and services. Then the key services of IBM Watson is Digital Twin, which is a separate offering that outreaches virtual replicas that allows simulation to be ran and able to perform various what-if analysis for efficiency improvement. The second is IBM Edge Application Manager, which is a separate platform that is used to build analytic application and used to deploy, monitor, maintain, and scale. Then next is the combination of relevant technology. The first is AWS IoT, which is a mixture of infrastructure as a service, platform as a service, and packaged software as a service. And it provides services across multiple data centers that are available in several availability zones across the world. EC2 provides the virtual server, S3 provides the scalable backup. Amazon Relation Database Service have option for Oracle SQL Server, PostgreSQL SQL, MySQL, MariaDB, Amazon and Amazon Aurora. Next is a Cisco IoT, which has 6 pillars. That is Cisco for computing, network connectivity, physical and cybersecurity, data analytics, management and automation, application platform. Next, the final one is the IBM Watson IoT, which uses the natural language processing and uses the machine learning in order to derive analytic conclusion to enormous unstructured data. And that's all for my part. Thank you, sir.
Hi, I'm Wayne Fong and I will be demonstrating our proposed system. As mentioned, the system would monitor the temperature of a room and notify the user if a room has abnormal temperature and the existence of people inside the room. Since we are using the Raspberry Pi virtual machine, the temperature sensor would be simulated using SenseHead emulator, where you can randomly set the temperature here, as you can see right here. Also, to demonstrate the person detection, a picture of a car and a person will be used as a dummy picture, which is shown right here. This is a picture of the car and this is a picture of a person. So to demonstrate this, I will first run the system with a normal temperature. Let's say 27, for example. So I need to subscribe this, and to run this, I need to run the script, which is lesson 3. New. As you can see, the IoT could receive the temperature right here, which is 27. And as for the DynamoDB, it is also has received the temperature right here, 27 degrees Celsius. So now I will be demonstrating the system when the temperature is above 70 degrees Celsius with no one inside the room. To do this, I will be using the same images, which is the car images, to demonstrate that there is no one in the room. So to do that, we need to set this temperature to above 70, like so. Then we will run the program again. As you can see right here, the IoT does receive the temperature and as well as the picture, which is as shown here. This is to tell the user that which images shows the incidents that happened during the day. For example, there is an abnormal temperature being captured during this day, this hour, and it is saved as a JPEG image, which is saved in the S3 bucket. And if I refresh this S3 bucket, you will see that the picture is right here. It is stored right here. And in the Amazon DynamoDB, the DynamoDB will also show the incident, the name of the image right here. And the temperature received is 71. And in the email, I will be receiving an email notification like this and stating that there is an abnormal temperature is detected in room A1 and there are no people inside the room. So now I will be demonstrating the system when the temperature is above 70 degrees with someone inside the room. In this case, I will be using the images, which is the person image right here. So to do that, I need to change the naming of this from car to Amazon, and as well as for this. save it, and then I will run it again. Yes, as you can see right now, this is the new data over 70 degrees Celsius. As for the DynamoDB, there is a new data as well, as you can see right here, which is this one, the lowest one, right? As for the bucket, we will also receive the images as well. But this time, when we go back here, yes, as you can see right here, the abnormal temperature is detected in room 1 and there are people inside the room. In this demonstration, the code is designed to run only once because due to the limited free tier availabilities. So to let this program run endlessly, all we need to do is just to put a comment right here to not the break statement to be executed. That's simple. That is all for the system demonstration. Thank you.
So that is the presentation from our group, and thank you for watching.